Table 250.66 does not limit the maximum size of the grounding electrode conductor. However, it does provide a minimum size. The required size of the grounding electrode conductor is based on the largest phase conductor connected to the transformer. In the case of the example, where the largest phase conductor is 1000 kcm, the minimum required grounding electrode conductor size is 3/0. Since the grounding electrode conductor is intended to provide a low impedance path to ground in the event of a fault, it is generally recommended to provide a grounding electrode conductor with an area that is equal to or greater than the largest phase conductor. Therefore, in this particular case, it is recommended to use a single 3/0 grounding electrode conductor. Now let's delve into the explanation of the equipment grounding conductor size. The size of the equipment grounding conductor to the metal container is governed by Table 250.122. This table provides guidance on sizing equipment grounding conductors based on the maximum possible fault current that can flow through the conductor. In an ungrounded system, the maximum fault current is typically limited by the impedance of the transformer. However, it is still necessary to provide an equipment grounding conductor that is adequately sized to handle any potential fault currents that may occur. Table 250.122b requires that the equipment grounding conductor be sized based on the largest phase conductor connected to the transformer, but not less than 8 AWG copper. In this specific instance, the largest phase conductor is 1000 kcm, so the minimum required equipment grounding conductor size is 500 kcm copper. Therefore, it is necessary to install a 500 kcm equipment grounding conductor to the metal container, even though a fault in an ungrounded system may not result in a large amount of current flowing through the equipment grounding conductor. This is because the equipment grounding conductor is intended to provide a low impedance path to ground, which helps to protect personnel and equipment from electrical hazards. Grounding electrode conductors and equipment grounding conductors play distinct but crucial roles in ensuring electrical safety. The grounding electrode conductor connects the electrical system to the earth, providing a path for fault current to flow back to the source, thereby tripping over current protective devices like circuit breakers or fuses. This connection to earth helps to stabilize the voltage to ground during normal operation and limits voltage surges caused by lightning or other transient events. The equipment grounding conductor, on the other hand, provides a low impedance path for fault current to flow back to the source from metal enclosures of electrical equipment. This ensures that any fault current will quickly trip the overcurrent protective device, minimizing the risk of electric shock. The size of the grounding electrode conductor is determined by Table 250.66 in the National Electrical Code, which bases the size on the size of the largest ungrounded service entrance conductor or equivalent area for parallel conductors. The grounding electrode conductor must be connected to a grounding electrode, such as a ground rod, ground plate, or metal water pipe. The size of the equipment grounding conductor is determined by Table 250.122, which bases the size on the rating or setting of the overcurrent protective device in the circuit. The equipment grounding conductor must be installed with the circuit conductors and must be connected to the metal enclosures of electrical equipment. In ungrounded systems, the equipment grounding conductor is particularly important because there is no intentional connection to ground. This means that a fault to ground may not immediately trip the overcurrent protective device, as the fault current may be limited by the system impedance. However, the equipment grounding conductor provides a low impedance path for fault current to flow back to the source, ensuring that the overcurrent protective device will trip quickly, minimizing the risk of electric shock. It's important to note that the size of the equipment grounding conductor must be adequate to handle the maximum fault current that could flow in the circuit. This is particularly important in large electrical systems with high fault current levels. The National Electrical Code provides detailed requirements for sizing and installing grounding electrode conductors and equipment grounding conductors. It is essential to follow these requirements to ensure electrical safety. The grounding electrode conductor connects to the earth, providing a reference point and a path for fault currents. The equipment grounding conductor connects to the metal enclosures of electrical equipment, providing a lower impedance path for fault current to flow back to the source. Both are critical for safety. In summary, the grounding electrode conductor size is determined by the size of the largest ungrounded conductor, while the equipment grounding conductor size is determined by the overcurrent protected device rating. Both are essential for providing a safe and effective grounding system. Grounding and bonding are crucial for electrical safety. Grounding provides a path for fault current to flow back to the source, stripping the overcurrent protective device. Bonding ensures that all metal parts are at the same potential, minimizing the risk of electric shock. The grounding electrode conductor connects the electrical system to earth, while the equipment grounding conductor connects metal enclosures to the grounding system. The size of these conductors is determined by the National Electrical Code, based on the size of the ungrounded conductors and the overcurrent protective device rating. In ungrounded systems, the equipment grounding conductor is especially important, as it provides the primary path for fault current to flow back to the source. Proper grounding and bonding are essential for protecting people and equipment from electrical hazards. The grounding system should be inspected and tested regularly to ensure that it is functioning properly. Any deficiencies should be corrected immediately. Grounding and bonding are complex topics, but they are essential for electrical safety. By following the requirements of the National Electrical Code and consulting with a qualified electrician, you can ensure that your electrical system is properly grounded and bonded.